Hey there, tech enthusiasts and retro gamers. Today we're diving into the fascinating world of retro computing. We'll be taking a trip down memory lane and giving a classic processor a modern twist. Buckle up, because things are about to get electrifying. Our star of the show is the MOS 6510 CPU. This little chip powered some of the most iconic gaming consoles and home computers of the 1980s. Remember the Commodore 64? That legendary machine brought gaming to the masses, and it wouldn't have been possible without the 6510. This 8-bit marvel was a workhorse, crunching numbers and pushing pixels with surprising efficiency. It was simple, elegant, and, most importantly, it sparked a love for technology in a whole generation. It's a testament to the ingenuity of early computer engineers. The 6510 might seem primitive compared to the multi-core behemoths we have today. But remember, this little chip was a giant leap forward in its time. It laid the foundation for the personal computer revolution, and its legacy continues to inspire today's tech innovators. Now let's fast forward to the present. We live in a world of 64-bit processors with multiple cores and lightning-fast speeds. These modern marvels can handle complex calculations and massive datasets that would have made the 6510's head spin. So, what exactly does this 8-bit to 64-bit transition mean? In the simplest terms, it's like comparing a bicycle to a supersonic jet. Both can get you from point A to point B, but the jet does it exponentially faster and with a whole lot more style. The number of bits in a processor refers to the size of data it can process at once. An 8-bit processor like the 6510 can handle 8 bits of data per clock cycle. In contrast, a 64-bit processor can handle, you guessed it, 64 bits of data simultaneously. That's an 8-fold increase in data crunching power. This leap in processing power has opened up a universe of possibilities. We've gone from pixelated sprites to photorealistic graphics, simple sound effects to immersive audio, and basic text adventures to sprawling open-world games. It's been a wild ride, and the journey is far from over. But what if we could combine the charm of the past with the power of the present? What if we could give the MOS 6510 a 64-bit upgrade and unleash its full potential? That's where the magic of emulation comes in. Emulation is like building a time machine for software. It allows us to run programs and operating systems designed for one type of hardware on a completely different system. In our case, we're talking about emulating the 8-bit world of the 6510 on a modern 64-bit machine. Now you might think emulation is as simple as translating code from one language to another, but it's much more complex than that. We're not just dealing with code, we're recreating an entire ecosystem. We need to emulate the CPU's architecture, its memory management, its graphics and sound capabilities, and even its quirks and limitations. It's like rebuilding a classic car from scratch, making sure every nut, bolt, and piston functions exactly as it did in its prime. One of the most exciting aspects of enhancing a retro emulator is the ability to leverage modern graphics technologies. We can take those pixelated sprites and blocky landscapes and give them a stunning makeover. One powerful tool in our arsenal is GLSL shaders. These little programs allow us to manipulate pixels in real time, creating effects that were unimaginable in the 8-bit era. We can add smooth anti-aliasing to eliminate jagged edges, apply dynamic lighting and shadows, and even simulate realistic reflections and refractions. Remember those chunky pixels from your favorite 8-bit games? With 1080p rendering, we can blow them up to high-definition glory. Imagine playing Pac-Man on a widescreen monitor with crystal-clear graphics. It's like seeing an old friend in a whole new light. But why stop there? With the power of modern GPUs, we can even introduce ray tracing to our retro emulator. Ray tracing simulates the way light interacts with objects in a scene, creating incredibly realistic reflections, shadows, and lighting effects. Imagine playing Tetris with realistic physics and ray-traced blocks. Section 5. The mighty transistor, a tiny revolution with giant impact. None of this would be possible without the incredible evolution of the transistor. This tiny semiconductor device is the building block of all modern electronics. It acts like a gate, controlling the flow of electricity and forming the foundation of logic circuits. Transistors have come a long way since their invention in the mid-20th century. Today's transistors are microscopic, measuring just a few nanometers in size. That's about 10,000 times smaller than the width of a human hair. This miniaturization has allowed engineers to cram billions of transistors onto a single chip. The more transistors we have, the more complex and powerful our processors can be. It's like building a city with billions of tiny workers, each performing a specific task with incredible speed and precision. The evolution of transistor technology is a testament to human ingenuity and our relentless pursuit of progress. It's a reminder that even the smallest breakthroughs can lead to giant leaps forward. Section 6, Silicon to Silicon, bridging the gap between eras. Now, you might be wondering how we can bridge the gap between the 8-bit world of the MOS 6510 and the 64-bit architecture of modern CPUs. It's a bit like translating between two entirely different languages, but instead of words, we're dealing with electrical signals and logical operations. This is where the ingenuity of emulator developers comes into play. They meticulously study the 6510's architecture, its instruction set, its memory map, and every quirk of its design. Then they write code that translates those 8-bit instructions into a language that modern CPUs can understand. It's a painstaking process that requires a deep understanding of both the old and the new, but the results can be truly remarkable. We can take those classic games and applications and give them a new lease on life, allowing them to run smoothly and efficiently on modern hardware. This fusion of old and new is what makes emulation so fascinating. It's a way to preserve our technological heritage while pushing the boundaries of what's possible. Section 7. Beyond the retro screen. Practical applications and future possibilities. Emulation isn't just about reliving the glory days of gaming. It has practical applications in fields like software development, digital preservation, and even education. For developers, emulators provide a sandbox to test software on different platforms without needing physical hardware. This is particularly useful for mobile app development, where emulators can simulate various devices and operating systems. Emulators also play a crucial role in preserving our digital heritage. Many classic games and software titles would be lost to time if not for the dedicated efforts of emulator developers. They're like digital archaeologists, excavating and preserving the treasures of our technological past. In education, emulators can be invaluable tools for teaching computer science principles. Students can explore the inner workings of a CPU, experiment with different architectures, and even design their own virtual machines. The possibilities are limited only by our imagination. Section 8. A community of passionate pixels, the retro revival. One of the most heartwarming aspects of the retro computing scene is the vibrant community that surrounds it. From seasoned veterans who cut their teeth on 8-bit machines to newcomers discovering the joys of classic gaming, there's a shared passion for preserving and celebrating our technological heritage. Online forums and communities are buzzing with discussions about emulation, hardware modifications, and game preservation. People are sharing their knowledge, collaborating on projects, and keeping the spirit of retro computing alive and well. This sense of community is a testament to the enduring appeal of retro technology. It's a reminder that technology is more than just circuits and code. It's about the connections we forge, the memories we create, and the shared experiences that bring us together. Section 9. The future of retro, a fusion of nostalgia and innovation. As we look to the future, the line between retro and modern technology will continue to blur. We'll see new games inspired by classic titles, innovative hardware that blends retro aesthetics with modern capabilities, and even virtual reality experiences that transport us back to the arcades of our youth. The future of retro computing is bright, fueled by a potent mix of nostalgia and innovation. It's a reminder that even as technology advances at a breakneck pace, there's always room to appreciate the classics, to learn from the past, and to find new ways to experience the magic of the digital age. So, let's raise a toast to the MOS 6510 CPU and all the other pioneers of the digital revolution. Their legacy lives on, inspiring us to push the boundaries of what's possible and to create a future where the past and the present coexist in perfect harmony.